FastMCP3's component versioning mechanism enforces strict consistency by preventing the coexistence of versioned and unversioned implementations under the same identifier, ensuring predictable behavior during version filtering operations. This design choice eliminates ambiguity in version resolution by requiring developers to explicitly commit to either a versioned or unversioned approach for each component name. We are about to examine how this consistency requirement manifests during tool registration, where attempting to mix versioned and unversioned implementations of the same function triggers an immediate validation error. The code will demonstrate the registration process and the resulting conflict that enforces this versioning policy. From FastMCP, import FastMCP. MCP equals FastMCP. At MCP, tool. Def calculate x, int y, int. A unversioned tool. Return x plus y. At MCP, tool version equals 2, 0, hash raises value error. Def calculate x, int y, int z, int equals int. Cannot mix versioned with unversioned. Return x plus y plus z. This code demonstrates FastMCP's strict versioning policy for tools, where mixing versioned and unversioned implementations of the same tool is explicitly forbidden. The pattern enforces consistency by raising a value error when attempting to register a version tool, calculate with version equals 2, 0, alongside an existing unversioned tool with the same name. The mechanism works by validating tool registrations at decoration time, ensuring all implementations of a tool either use versioning or remain unversioned. This design prevents ambiguity in version filtering, as unversioned tools would bypass version filter constraints, making it impossible to reliably filter them out. The error message clearly states the conflict, guiding developers to maintain consistency. This approach simplifies version management by eliminating edge cases where filtering behavior might be unpredictable. While it requires upfront planning, it ensures predictable behavior when using version filter to expose specific API versions to clients. The trade-off is rigidity during migration, but it prevents runtime surprises in version deployments. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, providing access to the Model Context Protocol Framework's core functionality. MCP equals FastMCP. Instantiates a FastMCP object and assigns it to the variable MCP. This creates a new instance of the Model Context Protocol Framework, which will serve as the core orchestrator for tool registration, versioning, and component management in the application. At MCP, tool. Def calculate x, int y, int. A unversioned tool. Defines a function named calculate that takes two integer parameters, x and y, returns an integer, and registers it as an unversioned tool in the FastMCP framework using the @MCP tool decorator. The docstring indicates this tool has no version specified. Return x plus y. Returns the sum of variables x and y. At MCP, tool version equals 2, 0, hash raises value error. Decorates a function as an MCP tool with version 2, which will raise a value error due to version mismatch or invalid configuration. The decorator registers the function in FastMCP's tool system while specifying its version identifier, but the provided version parameter triggers an error condition. Def calculate x, int y, int z, int equals int. Cannot mix versioned with unversioned. Defines a function named calculate that takes 3 integer parameters, 2 required x and y and 1 optional z, with default value 0. The function returns an integer and includes a docstring indicating it cannot mix versioned with unversioned components. The type annotations specify input and output types, but don't show implementation details. Return x plus y plus z. Returns the sum of 3 variables, x, y, and z. The expression evaluates each variable, adds their values together, and returns the result. FastMCP 3 enforces strict versioning consistency by preventing mixed versioned and unversioned implementations of the same tool. The framework validates registrations at decoration time, ensuring all implementations of a tool either use versioning or remain unversioned. This design eliminates ambiguity in version filtering, as unversioned tools would bypass version filter constraints, making reliable filtering impossible. The trade-off is rigidity during migration, but it prevents runtime surprises in version deployments. The error message clearly states the conflict, guiding developers to maintain consistency. This approach simplifies version management by eliminating edge cases where filtering behavior might be unpredictable, ensuring predictable behavior when using version filter to expose specific API versions to clients.
The decorator versions tools that refuse to exist. Registered names whisper to empty parameters.